Hi, I'm Shantanu. My group is Shelby and Hardik, and for our N6 final project, we implemented BlackJack in MATLAB. So as you can see, this is our intro screen. You can see BlackJack on the screen, and there's two buttons, one of which says instructions and one of which says begins. So if we click the instructions button, we can see these are the rules for our game. Um, So in blackjack, players compete against a dealer, aiming to achieve a higher hand value than the dealer's without exceeding 21. The goal is to get as close to 21 as possible without going over. Players do not compete against each other, they only play against the dealer. So at the start of the game, we have a standard deck of cards. Each player and the dealer are dealt two cards initially. So, and then one of the dealer cards is shown, one of them is hidden, all the players' cards are visible. So the card values are pretty much the face value. So 2 through 10, cards labeled 2 through 10 are valued 2 through 10. All face cards are valued at 10. And then an ace is valued at either 1 or 11, depending on which is more advantageous to the hand. So essentially, the goal is to get as close to 21 as possible without going over. If you hit a blackjack, like if you get 21 on the first hand, you immediately, unless the dealer also has a blackjack, which is a tie. So once you get your hand, you have two choices. You can hit, which means you get another card, or you can stand, which means you don't modify your hand any further. And the goal is basically you're competing against the dealer to see who will get closer to 21 without going over. So yeah, that's our rules. That's our instruction screen. So if we hit go back, as you can see, it brings us back to the main screen. Now, if we hit begin, it'll bring us to the actual game. So my contribution to this project was initially getting the project off the ground and implementing the GUI. So I created three mini apps: the intro screen, the rules screen, and the game screen that basically form the foundation of our app. And then just creating all the stuff for those apps, positioning everything, and creating the user interface as creating the GUI, the guided user interface, as was in our project proposal. So now we can see this is our game. We can see a little table. If we hit shuffle, we can see we have our stuff. So let's see, queen and nine, and king and queen. So let's say we decide to stand here. If we decide to stand, we hit the stand button, and it looks like the dealer didn't get more than that, so the players have won the game. Let's try and shuffle again. Okay, so now I don't know. We see a 9 and 6. Dealer has a king. So let's say we decide to hit on this one. Another card to modify our hand. Unfortunately, it looks like the card we got brought us over 21, and so we get a little notification that says game over, player one busted, dealer wins. And as you can see in our table, we're tracking all the results. So you can see what players got what cards on the table. And yeah, the deck shuffles, the table tracks everything. And yeah, so this is our game. And now I'll hand things over to Hardik, who will explain our code.
Okay, so as Shantanu rightly said, the basic goal of the blackjack game is to get as close to 21 as possible before the dealer does. If you get close to 21 as soon as possible before the dealer does, you win the game. But if you do not, you're busted. So to implement the game, what I had in mind was to shuffle the cards, two cards to each of the player and the dealer. And two cards which are like going to be distributed to each of the players are going to be dealt face upwards, so each of the players can see each of the two cards. But the two cards which are dealt to the dealer, one of them is face up and the other one is face down. So you really can't, the dealer can't really see what actually is in the second card, which is dealt face down. So what I did in this project was to write all the codes, like the calculate score, how the game state is actually implemented. So first I started by implementing the game calculate score method, which actually calculates the score of each of the players based on the value they have got on the cards. So this method initializes the score and the number of aces, then uses a for loop to iterate over each of the card in the card indices array. For each card, it retrieves the card name from a card names folder, which I have a folder on my laptop, which has like all the card images of the 52 cards and a back images. So a total of 53 card images in a PNG format. The images that you see on the game screen, which we just now played, it's all uploaded in the folder. So it just uses that, it converts the card images, like each of the images is like assigned a value. For example, 2 to 9 is assigned a value like the face values. the jack, queen, and ace is assigned a value of 11, and so on. So then I define the starter function, which defines each card names, sets the path to the card images, and like loads each card images to an array using for loop. Then I went on by like adding a callback to each of the buttons that you can see on the main screen. There's a shuffle button, a hit button, and a stand button. The functions of which like Shantanu described in the instructions, as you can also see. So for each of the like buttons, I've added a callback. Shuffle button callback method shuffles the deck using a random permutation function and deals two cards to each of the players and the dealers. Two cards face up for each of the players, and one card face down and one card face up for the dealer. Then the hit button push method increments the hit counts, adds a new card to the player's hand, and updates the display. It then calculates the new score and check if the player has like been busted or won with a blackjack using an if statement for a game over messages. Then lastly, the stand button push method, like it makes the dealer draw cards until their score is 17 or higher using a while loop, updating the display and recalculating the scores with like each new card. Yeah.
Great. And then for my section, I was able to introduce some animation and sound effects. So if we scroll here, we can see that the card flip animation. So to animate the card dealing process, we used a flip and show card function that's shown here. This function creates a visual effect where the card appears to flip over. So we display the card, back of the card initially, and then the card rotates through angles from 0 to 180 degrees in increments of 30 degrees. At each angle, the rotated card image is displayed using the I'm show function. Then for the sound effect integration, the sound effects are synchronized with the card animations to enhance the player's experience. When a card is flipped, a sound effect is played to match the visual action. So for loading and playing the sound, the audio read function reads the sound file, and then the sound function plays the sound during the animation sequence. It'll be shown here and in other places in the code. So for user interactions and feedback, players interact with the game using the buttons as mentioned previously, like shuffle, hit, and stand, and each action triggers animations and sounds to provide immediate feedback. So for example, this is the hit function, and you can see down here that there is the M show and everything that plays the sound at the same time. So the shuffle button shuffles the deck and deals the cards to the players and the dealer and calls the flip and show card function for each card dealt. The hit button adds a new card to the player's hand and displays it with the animation and sound. And then the stand button concludes the player's turn and initiates the dealer's actions. So in conclusion, both of these effects really add to the realism of the game and really help it make it a very enjoyable experience for the players. So, and then lastly, I was able to create a UI, or not lastly, second to last, I was able to create a UI table that keeps track of this data that's shown here for player 1, player 2, and the dealer. So basically, it was able to just keep track of what was played previously. And then lastly, we were unable to use the ThingSpeak integration, but we did sample and example this for the possibility if we were able to. So what this would have done for us is integrating ThingSpeak into MATLAB for a blackjack game for remote participants involves utilizing this capability for data collection, storage, and real-time monitoring to enable smooth remote gameplay and comprehensive GUI interface. This game data synchronization between remote players and tables is achieved by sending each player's actions and state updates to ThingSpeak channels instantly. A dynamically updating GUI table records game roles for each player using retrieved data. This setup allows multiple players to share game information in real time, ensuring up-to-date interfaces. Data logging and synchronization involves sending game actions and such, and basically, this is our example code for how that would do it. Define channel IDs and API keys, collect and send data, and then retrieve and synchronize that game data, and then update it based on the data. So this would really have been very helpful, but unfortunately, we were unable to do that because of the licensing. So that concludes my portion of what I contributed to the code.
And that concludes our overall presentation. Thank you.